Performing a regression analysis involves quite a number of steps, so we're going to break them down. The first one is to construct a scatter plot and investigate the nature of the association. So we're going to construct our scatter plot on the calculator using this data from the textbook. To construct a scatter plot, we go to Statistics. Let's rename our variables. So we've got age as our explanatory variable and price as our response variable. Once you've entered all your data in, we go to this button here. It's already on scatter, which is what we want. We get our X variable as age and our Y variable as price. Set that, and then this button to draw up the scatter plot. So this is our scatter plot. Now, if we're going to investigate the nature of this association, what we want is the direction, we want the form, and we want the strength of this association. We can see that it is going downwards, so we definitely have a negative direction. Its form, it doesn't look to have any curves in it, so I think it certainly has a linear form. And for the strength, in order to determine whether we're going to have a strong, moderate, or weak association, we can judge it by eye, but to properly gauge it, it's always good to calculate the correlation coefficient. To get our correlation coefficient, we go Calc, Regression, Linear Regression. Select our X and Y, and OK. So we've got our correlation coefficient as negative 0.964 to 3 significant figures. Now, because this is below negative 0.75, we can say that this is strong. So to write this in words, we can say that the scatter plot shows there is a strong negative linear association between the price of a second-hand car and its age, with the correlation coefficient equaling negative 0.964. There are no obvious outliers. Our next step in performing the regression analysis is to determine the equation of the least squares regression line. Now, because we are given our actual data, we can use method 2 that was described in 4b. We go to Calc, Regression, Linear Regression. Select X and Y again. On this page, we've got our A and B values in the form of Y equals AX plus B. So our regression equation, Y is equal to A, which is negative 3,900, and we'll round up to 40 because that's 3 significant figures. That's multiplied by X. And then we add B, which is 35,100, rounding down to 3 significant figures. Now remember, we can't stop here. We cannot leave it as X and Y. We need to put in our variable names. Our Y, or response variable, is the price of the car. So I'm going to write price is equal to negative 3,940 multiplied by the age of the car plus 35,100. Writing that in words, we have the equation of the least squares regression line is price equals 3,940 multiplied by the age plus 35,100. The next part of our regression analysis is interpreting what the intercept and the slope mean. Let's start with the slope. So we've got our slope as negative 3,940. What this means is, for every year that goes by, so for every time the age goes up by 1, the car's price is going down by 3,940. So we can write this as the slope of the regression line predicts that, on average, the price of these cars decreased by $3,940 each year. Now let's look at what the intercept means. We've got this equation. The intercept is what happens when age is equal to 0. You can imagine that if we had age of 0, the price would equal this intercept here. So when the car is brand new, it's got an age of 0 years, the price is equal to $35,100. So we can write this by saying the intercept predicts that, on average, the price of these cars when new was $35,100. Now our next step is to use the coefficient of determination to indicate the predictive power of the association. So what we need to find is our R squared value, our coefficient of determination. Two ways you can do it. You can use your calculator if you've already got the data in there, which we do. So let's go through the usual steps. And straight away, we've got our R squared value of 0.930 to 3 significant figures, or 93%. The other way to do it was to take our R value from before, negative 0.964, and we could have just squared that. So if we take negative 0.964 and we square it, we get 0.930 to 3 significant figures. Now if we think back to our template, back in chapter 3F, I believe, we can say that the coefficient of determination indicates that 93% of the variation in the price of these second-hand cars is explained by the variation in their age. Now, something that should also be noted is that because the coefficient of determination is so high, we can say that the regression equation has a highly significant predictive power. But in fact, any relationship with a coefficient of determination greater than 30% can be regarded as having a high predictive power. So any relationship with a coefficient of determination greater than 30% can be regarded as having a high predictive power, meaning we can use the least squares regression line as a good predictive tool. So if we've got this good predictive tool, it's natural that our next step should be to make some predictions. Now we can make predictions using our equation. We have the price of the car is negative 3,940 multiplied by the age of the car plus 35,100. So, as an example, let's find the price of a car that is 5.5 years old. What we need to do is substitute 5.5 in for our age. So we have price is equal to negative 3,940 multiplied by 5.5 plus 35,100. And we can pop that in our calculator. So the price is predicted to be $13,430. Now we can try and confirm this graphically. If we have a look at our scatter plot with our regression line through it, we can pinpoint points using this XY button here. We start on X is 4.5, so that's 4.5 years. Let's go across. Now we might not be able to get it exactly on 5.5, but we'll get it as close as we can. We can see when X, or the age, is 5.48 years old, the price is 13,562. Which is a pretty good estimate to what we had. So we should be pretty confident that we did our maths right here. Now, interpolation and extrapolation are not necessarily part of the regression analysis, but they are two key concepts that are very important when making predictions. If we can get this up to a full screen and zoom out a little bit. Okay, so interpolation is when we're making a prediction about a value that lies between the range of our values. So we've got our first values at 1 year old and our last value at 8 years old for the car. So as long as we're making a prediction between 1 and 8 years old, like before we did 5.5, this was interpolation because it's inside the range of the data. Extrapolation is when you're looking at the regression line outside of the data. So if you were trying to find the price of a car that was 10 years old, it actually lies somewhere out here, outside our last data point. And that is called extrapolation. So again, interpolation is predicting within the range of data, and extrapolation is predicting outside the range of data. When we're using interpolation to predict, our predictions are very strong because our regression line is within the range of our data. So predicting power is quite high for interpolation. We do encounter a problem with extrapolation though, because outside our range of data, we don't know if the regression line actually continues to be linear. For example, if we tried to go down to find out what the price of a car is when it's 10 years old, you can see that once we pass around 9 years old, we start to go to negative price, which doesn't make any sense. So extrapolation is not always great at predicting, and interpolation is. The final step in our regression analysis is the residual plot. Now we spoke about residuals back in chapter 4a. Now to jog our memories, I've drawn a very, very basic scatter plot here with a least squares regression line. The value of the residual is the distance from the actual value to the predicted value. This means that residuals can be positive, where the actual value is above the least squares regression line. Residuals could be negative when the actual value is below the least squares regression line. So the residual value is equal to the actual value minus the predicted value. Let's look at an example of this. Let's look at the point on our scatter plot where the age of a car was 6 years and its price was 6,500. So the actual value was 6,500 when the age was 6. What is our predicted value? Well, we just need to plug 6 into our least squares regression formula, which I've still got up here. So plug 6 in there. Our predicted value is equal to 11,460. Therefore, the residual is equal to 6,500 minus 11,460. Which is negative 4,960. Now clearly doing this for every single point would take forever. So there is a way we can get these values onto our CAS and actually plot the residual. Now we're going to go to the familiar spot, going calc, regression, linear regression. Select our appropriate X and Y variables. What we want to do here though, if we select copy residual to say list 3, what it's going to do is it's going to post all of the residual values into list 3. So we hit OK. And we've got all our residuals here. So far, we already had our data entered. We went calc, regression, linear regression, selected our appropriate X and Ys, and we selected list 3 for the copy residuals, which gave us the list. Now we want to hit this button to set up our scatter plot. We want our X variable to stay the same, but instead of price for the Y variable, we want to plot list 3. That's going to plot the residuals against age. And hit set. And then, I missed a step. Then we need to hit the button that looks like that over here. And we get our residual plot there. Now the reason that the residual plot is important is because if there's no clear pattern in the residual plot, then we can assume the association is linear. So we can see here that the plot looks fairly random. All right, these residual plots aren't following any sort of pattern, which means that we are allowed to assume that the association between age and price is in fact linear. If it looked like there was a pattern going on with this residual plot, let's say there was a big curve, or maybe they were all tending upwards, then possibly we should never have assumed that there was a linear relationship between age and price. Usually you can see by eye, by the scatter plot between age and price, whether the relationship is linear, which is what we did at the very start. But the residual plot is able to pick up very small differences. So this is an even better way of assessing the linearity between these two variables. So in words, we can say from this residual plot, a lack of a clear pattern in the residual plot confirms the assumption of a linear association between the price and age of a second-hand car. Okay, now that was our last step of the regression analysis. if we go back to the start, each section that I've written in blue should be put together into a report. So the first part of the report talks about investigating the nature of the association in terms of the scatter plot. The next part talks about what the equation of the least squares regression line is. After that, we interpreted what the intercept and the slope meant. Then we used the coefficient of determination to indicate the predictive power of the association. We did make predictions and explain interpolation and extrapolation, but these parts do not need to be included into the report. And finally, we used a residual plot to determine whether the assumption of linearity is appropriate. Now, putting all those together into a report, you will see, to save me having to rewrite them all together, your textbook has got this report put together for you. Now, this regression analysis that I've gone through here spans from page 141 right through to 147, if you want to read through it yourself in a little bit more detail. Because this video is already super long and has contained a lot of information, I'm not going to go through any extended examples here. I will make a separate video for that. The purpose of this chapter was essentially to put everything you've learnt from almost chapter 3 onwards into one big regression analysis, putting all the pieces of the puzzle together. The main takeaways though, the only new pieces of information that we really learnt were how to make predictions using the least squares regression line, what the terms interpolation and extrapolation mean, and probably most notably, what a residual plot is and how it can give us an insight to whether our assumption of linearity is appropriate or not.